My name is Forrest Mid, Cloud Solutions Architect with Microsoft. I'm on the Data and AI team. Today what we're going to do is we're going to pick up from our last conversation. So I encourage you to go back and look at that video. I'm going to skim over a lot of those activities that we did. And today what we're going to focus on is using Azure Synapse Analytics. We're going to use Azure Machine Learning. And we're going to connect and do all that work through Azure Synapse Spark. So just as a quick recap, what we did was we had a zip file. We used Azure Data Factory to take that zip file and load that into our storage account. We unzipped it. Then what we did was we used Azure Synapse Serverless, created a database and a view. And with that view, then we did some light enrichment and modification of that data. Then what we did was we used Azure Synapse Spark, and we connected to the serverless, pulled that serverless view into the data frame, and then used Python to walk through a time series forecast strictly with Python. All right, so where we're picking it up today is we want to compare and contrast then using Python, straight Python and Azure Synapse Spark versus the benefit of maybe using Azure Machine Learning. The process that we'll go through is essentially trying to compare the two. And ideally through Azure Machine Learning, what we're doing is instead of picking a statistical algorithm to leverage, we're going to let Azure Machine Learning, go through and score each of the models. And then based on the scoring, that will become effectively the best model, the best fit model. And then from there, we'll use that model to then do a 12-month projection. And then what we'll do is we'll take that 12-month projection, marry that up with the actuals, so then that we have a 12-month, actuals, and then the projected 12 months is what we're after. Okay. Now this discussion that we're going to go through today is not going to be, it's not a cookbook, right? I'm going to go through and show you the output of this, focusing a little bit more on the setup and how the setup and leveraging some of specifically the Spark database table to generate a lot of the code for us. So that's what we'll see here. But we're going to go through start to finish, trying to keep this, like I said, pretty much focused on target with what we're after. Right, so to begin with, what we'll do is to do just a quick recap. In order to connect to the serverless database, which is being represented, if I get my mouse to behave here, what we did was we have this view. And this view, again, going back to the prior video that I did, you can watch all the details associated with that. But we're going to be working with this view ultimately to create essentially the Spark database table, STL compressed. So let's take a look at that. First, to get started with this, with Spark, in order to connect Spark to the serverless, this is the approach I took. You will need these libraries. I then used the connection, and there's some documentation here from one of the engineers, and then the process I went through. So what we do is we connect to the serverless view. That's what we're seeing here. We're connecting to the server, and we're going after the view vcompressed that we're looking at here that was created earlier. From here then, we do some light manipulation of that data to ultimately peel out only one sales rep, the 12 months, and then aggregate the cells. And then from here, what we'll do is we'll take that data frame and we'll write that back to the Spark database table, STBL compressed, which is what you're seeing here in the Spark database. Okay. All right. So setting up, let's talk a little bit about this, because if you're new to this, this is going to be, I guess there's parts of it that's well documented, and then I suppose there's parts of it that are not that well documented. So let's just explore that. So what I did here is I've got a couple of links here. This is going to be the first thing that we need to do is we need to configure the machine learning, Azure Machine Learning with Synapse. This link will walk you through the steps. In short, ultimately what you're going to end up with is within your linked services you're going to have an Azure ML service that's linked within Synapse. That's going to be critical to then deploy the data frame to Azure Machine Learning for it to run through its models. The second thing that we'll need to take a look at is once we get into the anomaly detection, these two links will walk, these two are actually really good. It'll walk you through that configuration. Ultimately, what we're after is setting up Key Vault, setting up the cognitive service for anomaly detection, and then all that gets combined into, and you'll see here we have the Azure Key Vault, we have the anomaly detection, and then we have the anomaly detection service that's actually using the Key Vault here. I'm sorry, this Key Vault, disregard this one, the Key Vault, and then the anomaly detection service. And we'll see this reference. I'll refer back to this again in just a few minutes. Last, what I want to do is just call out, this is a really good video. There's probably many I'm not trying to highlight, but this was done by Megan Quinn over at Blue Granite. I encourage you to walk through this. Take a look at what she did. It's going to be very similar. The key differences is I'm going to show you a little bit more on getting the setup and the configuration and how we can generate that, without having to know, from scratch just how all this code gets written. All right, so the first thing that we need to do is we need to train a model. All right, so why am I using the Spark database table? Well, let's take a look at that. So this is ultimately what we're going to be starting with. If I click on this and select Machine Learning, train new model, and I select Time Series Forecast, what we'll do is then we will select the target column of sales. Notice the format is decimal, and then we'll select the Apache Spark pool. On the Apache Spark pool, you need 2.4 or greater in order to work with Azure Machine Learning at the time of this recording. Okay, so if I go ahead and select Next, and you'll notice this is going to create our data set, and this is going to basically create the model dash best. If I select Continue, what we'll do in the time column, we're going to select the invoice date. Notice that is a date type field. And then on the auto detect, what we're going to do is set that as a 12-month horizon. Ultimately, we're going to basically create a data frame with 12 months of no data in it, and then run that through to get the projection. Now, on the primary metric, what we're going to do is I'm going to leave it as the default normalized root mean square, but notice there are other scoring metrics here to determine the best fit of the model. I don't want to give it away, but I'm actually going to walk us through a model that really does not fit the normalized root mean square. And as we get to the end of this, I'll explain more about that. So once you have those configurations set up, if you select Open in Notebook, this generates into the Synapse notebook. It gives you all the code that you need. Okay, and so it gives you the name, it gives you the data set that is creating, the 12-month horizon that we're going to be setting. There's actually some other configurations here for explaining the model, but ultimately what this does is it gives you all the code you need to execute and run this. Okay, so what I'm going to do is switch back because we modified that just a little bit in the model. What I'm doing is we've added this in for the train and the test. This is actually the best practice to walk through. Now you'll notice I have a 2-year time frame that the first 18 months is going to be the train. The last 6 months is going to be a test, or often referred to as a holdout set. So here what I'm able to do is control, in this case 75-25, to train the model. Most, I say in general, what I see mostly is 80-20. And so that's important because you'll see here in a few minutes as we get further along in this, you can control the time frame that you're going to use to train your model. Okay, so that'll be really important later. Don't want to give away the secret here. All right, so that's all I've done, and then the only thing I changed is notice here I've got df train. versus the syntax that would have been auto-generated is just df for the data frame that is being defined within, that you don't see, but this is giving us control over the training of that model, or the time, the data set that's being sent to train the model. That's the key takeaway here, and that's why that's important. All right, the rest of this, we just go through. You can change the experiment hours. I set it for 3. This actually it can take 2 to 3 hours or more, depending on the data set. You could also do it and just set that to 0.25 to make this run really fast to get all this set up if you wanted to go through, versus waiting 3 hours to go through the actual output. You'll just run each of these on that cluster. You'll run, this is the part where it'll actually take and it registers the data set, and this process can, like I said, can take a couple hours, 2 to 3 hours. All right. So once that's been finished, what do we have? Let's go over to Azure Machine Learning, and let's start at the beginning here, and let's go to AutoML. So this would have been the model or the experiment that I created, and I named it in mine. This is the name of the experiment that I created. And if we go then to the actual run on this, we'll go then to the models, and then this shows us the models that were used, and there's quite a few here. There's, like I said, there's quite a few models in here that were used, and based on the scoring, normalized root mean square, it came up with this being the best fit model for this run. Now, the piece of information in here that's going to be critical is if we go over to the models, let's go back into, this is our best fit model, and if we go to the artifacts, this is the piece of the information that's going to be critical to continue on for scoring and forecasting, ultimately, is the ML model and the model.pickle. All right, so that's what's critical when you train the model. That's what's sitting out there. And now then what we're going to do is we're going to continue on, and now then we're going to score the model based on the holdout set. Okay, so that's what we're going to be doing now in this next piece. Right, so I've assumed that the cluster had stopped, and that's why I'm re-importing some of these, but like for example, the pickle wasn't in the other. So I broke this up into 4 different areas so that you could, experiment, might be the way you want to set it up, to where now then you can tinker around based on these different areas. Okay. All right, so we're going to go back in, we're going to grab the name of the model that was the best fit, which is simply the name of the model-best, or experiment-best. We're going to go to those artifacts to get the pickle model and the ML model. And now what I'm going to do is, remember on that df train test, I wrote that out to here. I wrote that out to the Spark database table. So what I'm going to do now is call that back into a data frame, and I'm going to change that from a date type to a timestamp. The reason why I'm doing that is because it turns out that's the format that it needs to do the projection. And now that I'm going to create a data frame, within the data frame, I'm going to create a column, and now I'm going to put in the forecasted values based off in this 0 in this and the tuple. That 0 references this first field, invoice date, and it gives me now then my predicted values. All right. So eyeballing these gives you one perspective. You could also chart them, and it actually shows you that the model really was not a very good fit, in my opinion. Is this an anomaly? Is this a seasonality? Right? So these big swings like this will have to be taken into account for. My background was accounting. I've spent over 32 years trying to, refine a process that could, automatically find this. I've never been able to find it. It's really tuning a model and, using the variables, trial and error testing. So what I'm trying to emphasize here is that because it didn't fit, don't give up. There's, statistical forecasting or modeling is an art and a science, And so that's why I'm showing this. A lot of the demos and examples that you'll see from vendors, everything just fits. The world is perfectly clean, the data is perfectly clean, there are no anomalies, and it gives you this projection. And see how great our tool is. Well, I'm trying to explain here that it doesn't always work that way in practice. So what I'm going to do here, excuse me, voice is giving out on me. What I'm going to do here is just write this back to a scored database Spark table, referenced here, scored. And that's all I'm doing. I'm just storing it back out into the database for maybe later reference. All right, now the anomaly detection. If the scoring didn't tell you already that there was an issue, what we're going to do is use anomaly detection. This is actually a optional, but it is a best practice. When you go through and you create your model and you score it and you do anomaly detection, you definitely want to incorporate this in. All right, so what we'll do is we'll come down. What I'm doing here is I'm pulling back now the original data set, all 24 months of data that I originally had created from the data set. And you'll notice now what I'm doing is I'm going to cast and change the date format. I'm change the format here and change this column to double. And the reason for that is because it's actually the format that we'll have to have, otherwise you'll get errors. So that's what I'm doing. And then we also create a column called group. This will be required in the anomaly detection to do a group. And these series, there could be a variety of different series depending on the product or whatever it is you're forecasting. There may be multiple series of these, and that's why you have that reference there as series 1. Okay. All right. So where did this code come from? Right here. Well, if we go to back to this Spark database table, and if I were to select machine learning, and I was going to select predict with a model, and I were to select anomaly detection, it's actually going to generate most of the code for me. Now, if you do not have your cognitive service linked or machine learning linked, you will not be able to select the links. You'll have to have this link service. This is actually the name of the service. Remember the anomaly detect service that we created in the link service? That's the name of that. The granularity is going to be monthly. The timestamp is going to be invoice date. Notice the date field. Date type. And the time series value is going to be sales. Notice I've got decimal there. And the grouping, what I did is I'm just going to use it based off the sales rep to give me a grouping. And if I open this up in Notebook, it gives me all the code that I need to generate that. So pretty slick. All right. So we're going to go back to our anomaly detection and take a look at this. So once I run this, what you'll have is over here, if we scroll down to September, right here. So what it's doing, let me close this back up and let me show you an example of one that's not. If we take a look at the previous month or any of these months, what you'll see is you have an expected value and it has an upper and lower margin of value to be falling within. If it falls within there, it's not considered to be an anomaly. An anomaly could be seasonality, it could be anything. It's really just bringing to your attention it fell outside the range that was expected. And if we look here where we do have anomaly as true, you'll see that the value actually is not falling into where it ought to fall within the upper and lower margin. So what I'm going to do is write this out to anomalies to be used later. And then we have a query, then I'll just, off that data frame, I'll just say is anomaly true to give me that 2016 0901 to show me that anomaly value. Okay. So that's all we're doing there. Now on the general forecast, what we're going to do is we are now going to take the all 12 months, the entire 24 months, 24, I said 12, the entire 24 months, And we are going to create a projection off that. But in order to do that, what we're going to first do is create a time period that we're going to be doing the projection. Remember, our model was trained for a 12-month horizon. So in this example, I've got my start date at 2017-01 to 2017-12. And then what we'll do is we're going to create a data frame using this syntax to give me, and you'll notice I'm writing that back as the, my table name is my forecast. What we're doing now then is we're creating that time frame for the to be able to do that prediction for this particular date period. Okay. Next, what we'll do is we're going to go back to the machine learning service. We're going to grab the model, and then what we're going to do is we're going to call that back up. And at the end that I was still here, I really could have just used the data frame that was already described above, but I'm just going to call it back from where I wrote it back from the Spark database table. And what we're going to do is change that back to a timestamp, because that's going to be required for this to work. And then we create the, just like we did in the scoring, we're going to create a new column called predicted value, and we're going to forecast that data frame that we had created here, and we're going to get the predicted values. Okay, and then that's our forecast. And now then what we're going to do is we're going to write that data frame back as the predicted data frame. And what we want to do now is marry these two data frames together, the 24 months of actuals. And what I'm doing here, if we look at the predicted that we just created the data frame, we have a timestamp and double for values. Whereas on the 24 months of actuals, I've got a date and a decimal. So what I'm going to do is switch those back, marry these two data frames together, and that gives us then our data frame join, which is the union of these two data frames. You will not be able to union this if you do not have the same column lineup, right? So what you're seeing here is I'm creating the sales zeros predicted value. I'm creating a column for the predicted values. Otherwise, you'll get an error. Either the data type or you don't have the columns lined up to have the same columns for each of the data frames that you're joining together. Okay. What I'm going to do here is just create a temp view, an example of using SQL. I'll write SQL against that data frame, and then this ultimately is what you get on the output here with the 24 months of actuals and the projection being represented here. Again, not that great of a projection, but again, I want to emphasize that you want to look at statistical modeling as the time spent in the model. You can get very accurate. You absolutely can tweak the model, adjust the model to be extremely accurate, but it is not a one and done process. So remember, as you're working with this, if you don't get the results, it might require additional training of the model, might change the scoring methodology. You may need to adjust the anomalies. If it is an anomaly, maybe it should be adjusted. You take out the anomaly that might have occurred. Maybe it was a sell-off of product. Ideally, what I would be probably more inclined to do is be doing a projection of units, and then on the projection of units, multiply times the price. So both in this example, when I'm just doing sales of what, right? So, if there was a year-end inventory sale and we did huge discounts to, get rid of product, I would consider that an anomaly, where the product now is being discontinued and we just want to get it out of inventory, maybe recover some of the cost of sale for that product. So like I said, these conversations, creating that model is really an investment. It's not just a push of a button and you've got your, the clouds part and you've got this incredible forecast where everything is just simple, easy. It does require a lot of investment and time in working with this, but it does have a huge payoff. Okay. So just as a quick recap, I'll come back to the beginning here. Our primary objective that when we were looking at this is we were taking CSV files that were compressed, joining them or taking them from on-prem using Data Factory into Data Lake. We did some light cleansing of that data using Azure Synapse Serverless. But remember, Azure Serverless is a shared resource. I spoke quite a bit about this in a previous recording on this, and I encourage you to take a look at that one. But from that, we did some light manipulation. In order to do heavier manipulation, in this example, you have a choice. You could use the compute of a SQL environment, or you could spin up compute using Azure Synapse Spark. I chose Spark to go through the examples of a time series forecast, and then from there I used the connection within Spark for the cluster to connect to the Synapse Serverless built in, bring that data into the data frame, do my manipulation, whether it was straight Python or I used Azure Machine Learning. Azure Machine Learning allows me to iterate through a variety of different models to find the best fit, versus if I'm just writing Python, I'm working, each model that I bring in, I run through to come up with the best fit, right? So there's trade-offs there. But the takeaway then ultimately is once I create that data frame, I either send that right back into a SQL environment so that I can then view it through Power BI. I might send it back into the data lake to then view Power BI, or put it in a gold or curated folder for others to consume with other presentation tools, whatever they may be. So that sort of concludes these two discussions. Any one of these discussions could be very, very long. So I encourage you to reach out to your solution specialist or your cloud solutions architect and ask them to go deeper in any one of these areas where we may have erred on brevity, to keep the time frame here to being short and concise, not go through the whole cooking process, but basically get to the end entree. In this case, a best fit model for time series forecasting. So I appreciate it. Thank you very much.